The goal of our project is to use data from the last 14 years of UFC fights to determine what factors are most important in predicting winners and to train a model that predicts the winners of matches with relatively high accuracy. This dataset describes UFC fights, with each entry containing information about every match since 2010. Each entry includes the fighters, betting odds, variables describing each fighter and their fighting style, and their win history, as well as several variables about the fight itself. A unique aspect of this dataset is that it includes the betting odds and favorites, so there's a standard metric to compare our predictive models to. By establishing a baseline prediction using the betting odds, we can compare the accuracy of our models to this baseline. In the distribution of fight winners categorized by red and blue corners, the data shows that blue corner fighters are slightly favored to win, having won approximately 3,300 fights compared to the red corners' 2,700 fights. These variable distributions show that there are many similarities between fighters in a match. In the height distribution, the difference between the heights of the fighters clusters around 0, meaning that large disparities in height are rare. The same follows for reach difference, so disparities in reach difference are also rare. Age difference is normally distributed, with most differences falling in the range of 0 to 10 years, so fighters are typically of similar ages. The correlation heat map presents correlations between different features, offering insights into how they interact with each other. For example, the losing streak difference and loss difference have a correlation of 0.1, which is a moderately strong positive relationship. This suggests that fighters with a larger losing streak tend to have a higher number of losses. Win streak difference and win difference have a strong positive correlation of 0.67, indicating that a fighter's win streak increases along with their overall win performance. The longest win streak difference and win difference has a positive correlation of 0.49, showing that fighters with a long win streak tend to have a higher number of overall wins. Height difference and reach difference has a moderate correlation of 0.63, indicating that taller fighters often have a reach advantage. Knockout difference and win difference has a positive correlation of 0.64, meaning that fighters who score more knockouts tend to have a higher number of wins. And finally, age difference has low correlations with most other features, implying that age differences have little effect on the fight performance metrics. Winner has very weak correlations with other variables, suggesting that there is no single feature alone that strongly predicts the outcome of a fight. The red odds and blue odds columns can be used to determine the favorite and the underdog. When red odds is greater than 0, it means that red is the favorite and blue is the underdog, and blue odds and red odds cannot both be positive or negative at the same time, so we can use this to calculate the probability of the favorite winning the match compared to the underdog. The probability of the favorite winning is 65%. We fit 2 logistic regression models, one using the variables with the highest correlation with winning, and the other using a variety of variables. There are a few slight negative coefficients, such as win streak difference, which suggests that if a win streak difference increases, the red fighter is more likely to lose. Age difference also has a negative coefficient, suggesting that if the blue fighter is older, they're more likely to win. However, because all of the coefficients are relatively small, there might be random errors or biases that are hard to predict. Additionally, weight class and stance have relatively large coefficients, suggesting they play an important role in determining outcomes. Our logistic regression model achieved an accuracy of 0.6%. We fit another model, a multi-layer perceptron model this time, that achieved an accuracy of 0.59%, but both of these are less accurate than the baseline of simply betting the favorite. We fit 2 decision tree models, with the unpruned model achieving an accuracy of 99% on the training data, but 54% on the test data, which is an extreme case of overfitting. We used cost complexity pruning to create a simplified decision tree, which achieved a training accuracy of 58%. Looking at the resulting tree, most of the index values are around 0.5, indicating that it's difficult to distinguish these features in their outcomes. Finally, to counteract the overfitting we noticed in the unpruned decision tree model, we used XGBoost to include regularization parameters. Through randomized search cross-validation, we achieved a testing accuracy of 0.61.